Hello, everyone. Welcome to Cloud Native Live, where we dive into the code behind Cloud Native. I'm Annie Talvasto, and I'm a CNCF ambassador, as well as I lead marketing at Vision, and I will be your host tonight. So every week, we bring a new set of presenters to showcase how to work with cloud native technologies. And as always, they will build things, they will break things, and they will answer all of your questions. So you can join us every Wednesday or in a couple other days, such as today and Tuesday, to watch live. And this week we have Reza here with us to talk about troubleshooting eBPF data plane in Kubernetes cluster. I'm very excited for this. And as always, this is an official live stream of the CNCF, and as such, it is subject to the CNCF code of conduct. So please do not add anything to the chat or questions that would be in violation of that code of conduct. So basically, please be respectful of all of your fellow participants as well as presenters. But with that done, I'll hand it over to Reza to kick off today's presentation.
Thank you, Annie. So let me find my slides somewhere right here.
No worries. And I can see that Andrea asks, will this event be recorded for later view? And I can happily say that yes, this will be recorded. And you can watch it, for example, from the CNCF YouTube page, from the live streams tab. You can find all the previous Cloud Native lives from there. So no worries. If you missed something, you can always go back in the recording and check it out.
All right. So now that we know this is being recorded, we can dive into the stuff. So hello, everyone. My name is Reza. I'm a developer advocate at Tigera. Tigera is the company behind open source Project Calico, where we do everything in terms of security, networking, and the cloud native scene. I'm always eager to learn new stuff and open to suggestions. So if you got an idea or you want to explore anything, let's connect. You can usually find me in Calico user Slack. I believe if you're watching this from LinkedIn, you should be able to click on my profile as well. I'm pretty easy to find. So for this presentation, I'm gonna talk a little bit about cloud networking, and then give you a brief overview of Calico eBPF advantages. Then talk about troubleshooting, because without talking about these fundamentals, it would be very difficult to explain why we need to build new tools to troubleshoot eBPF. Anyways.
Yeah, and there was actually a quick question from the audience. Maybe you will answer this later on, but there is a question, what is eBPF actually?
So eBPF stands for Extended Berkeley Packet Filtering. However, at this point, it's not really about packet filtering. It's a sort of a virtual machine that runs inside the kernel, I guess in a couple of months or years in Windows as well, that can directly execute commands or interact with the kernel. It offers a lot of performance, and you can basically do a lot of stuff that are very expensive in terms of resources with it, that are very expensive if you want to do it in other ways. So as eBPF. So Project Calico, if you like to connect with us, these are our social handles. Project Calico is all about cloud networking and security. We got a lot of Slack channel members and a lot of contributors. There are a lot of nodes that are covered by Calico every day. And the beauty of Calico is it's an open source community. So you can just take the code, change it, and submit it to us, and we'll include your contribution in the code base. So let's talk about cloud networking first. Now, modern applications are mostly hosted on the cloud these days. Oh, by the way, I forgot to mention, if you got any questions, please ask. Annie would help with the questions and read them for me and between the sessions. There is also a Q&A at the end. So depending on how the stream goes and how the demo is working out, we might have time to answer your questions in the beginning or in the middle of the stream or at the end. If I don't know the answer, which by my experience is most of the time, I'll try to find one of Calico developers and engineers who know a lot more about these sort of stuff to answer your question. That being said, the best way to get answers about Kubernetes and everything cloud native is that project Slack channel. There are a huge number of community members and engineers who are always present in these project Slack channels that be very happy to answer all your questions. With that being said, modern applications are mostly hosted on the cloud these days. Cloud computing allows companies of all size to offer their services without investing in infrastructure and data centers. On top of that, cloud computing offers unparalleled flexibility and scalability that can quickly be tuned to your needs. But this magical experience is possible by utilizing the power of cloud networking. Kubernetes is one of the main contenders in running a cloud environment. On its own, Kubernetes is a modular architecture, a modular orchestrator that gives you the required setup to run and scale your workloads. In this presentation, our focus is going to be networking side of the Kubernetes, but at the end, we're gonna troubleshoot how this networking is actually provided by eBPF. Now, Kubernetes cloud networking has two parts, a physical networking infrastructure and a cluster networking infrastructure. Now, physical network infrastructure is the fundamental building block that connects your cloud resources to other networks. It could be on-prem or the internet, any other networks, or maybe sometimes other resources inside your network. And it is usually managed by the cloud providers in the public clouds and the networking department of your enterprise in private clouds. This layer is comprised of cables, switches, routers, firewalls, you name it, it's there. The other part of cloud networking is the cluster internal networking. In a Kubernetes cluster, this is managed by your cluster CNI plugin. This CNI, the CNI uses a software-defined networking, or SDN, to provide connectivity between your workloads and either internal or external resources. While there are some standard features that most CNIs provide, each one has a unique take on networking. For example, Calico is built with a modular architecture. to provide you with the most flexibility and gives you a pluggable data plane that allows you to switch between technologies at any time that you desire. So, as I mentioned, it is modular. The data plane for Calico is modular. So, its architecture is similar to Kubernetes itself. It offers multiple choices that gives you the freedom to tune your cloud environment in the way that is the most optimal for your scenario. Today, Calico offers 4 pluggable data planes that can be switched on depending on your needs and environment. Starting with standard data plane, it's based on IP tables, provides fast networking, security, and compatibility to all environments. Calico eBPF, which is our focus for today, is another data plane created by Tigera, which uses the power of eBPF programs to provide blazing fast networking and security for your environment. eBPF data plane offers capabilities such as complete proxy replacement, source IP preservation, and DSR, and a couple others. If you're running a hybrid environment with your Kubernetes, you can use Calico for Windows, which is based on Microsoft HNS or Host Network Service, and can deliver networking security to your Windows nodes. VPP is the newest data plane for Calico. It was an external contribution from Cisco. Currently in its beta phase, which accelerates the networking experience by utilizing the power of user space programming. Now, why I'm talking about these in an eBPF stream? Well, this is the catch. So eBPF, as I mentioned, is a technology that runs inside the kernel. So everything that you try to establish is directly injected into the kernel at the lowest level. VPP is at the user space level, which is like the highest level possible for a program to run. Now, you might think, well, the kernel is faster, or you might think the user space is faster. Well, the thing is, depending on your scenario, each one can have different performance. And what is important is to check everything out, do your due diligence, and figure out which one works for your scenario. In fact, eBPF and HNS are some of the technologies that we use in our commercial offerings too. So to keep short, we're going to explore the standard data plane first. Now, the standard data plane is built on the Linux networking stack. It utilizes the power of IP tables to communicate with the kernel and pushes network boundaries as much as possible. The setup has been battle tested in every possible scenarios, and I think companies like OpenAI, Reddit, like big companies, are dependent on it to serve their customers. Calico eBPF data plane is another data plane, as I mentioned, utilizes the power of eBPF programs to directly interact with the Linux kernel, implementing network for your cluster. Now, standard Linux data plane has a high throughput, and it was designed for 10 gigabit links. Policy enforcement is very fast, and Kubernetes services are fast in it. It is flexible, and you can change its behavior very easily. The best part about standard data plane is that anyone can change its behavior to some extent. Now we're getting to the parts that will be included in the troubleshooting. So standard data plane is really easy to troubleshoot. In fact, anyone can face a problem and search it in a Stack Overflow or any other forums to figure out how it can be saved, how it can be solved. But with eBPF, um, it's a little bit more difficult because, again, everything is a binary or is a program that runs inside the kernel. So eBPF data plane is designed for 40 gigabit links or more. It has a higher throughput while consumption or its resource consumption is less than standard data plane. Keep in mind that this is not something that all eBPF data planes might share. Everything is different. Again, the broad the thing is, eBPF on its own is a tool, and depending on how you use it, you will get different results. Uh, at the end, you would accomplish one goal. Let's say you would move packet A from source to destination, but depending on how you're programming your data plane, you might get different performance and different benefits. It offers a faster policy enforcement since eBPF policies are compiled as eBPF programs and are injected directly into the Linux kernel. Kubernetes services are faster since eBPF data plane implements them via eBPF programs inside the Linux kernel. So you don't have to go through Netlink and to IP table. And with Calico eBPF data plane, you have more flexibility to control or manipulate traffic since you're directly interacting with the kernel. So I talked about the difficulty of troubleshooting. Now, troubleshooting eBPF programs, as I said, can be difficult. And since eBPF is a fresh idea and lacks the amount of resources or the questions that were asked, for other technologies like the IP tables, you might find yourself a little bit discouraged, but don't be, because each project that uses eBPF usually ships a troubleshooting tools that can peek into their eBPF programs to give you some sort of output or some sort of information or insight. Uh, the thing that is important is to know that all these eBPF programs that are injected into the kernel are binary files. So if you're trying to use eBPF, make sure that you first go to the troubleshooting page of the project that you are choosing and figure out what utility can be used. Today, I'm going to show you how Calico BPF troubleshooting works. If you like an actual comparison in numbers about BPF, you can check this article. It talks about different data planes, how IP tables and eBPF work together, how IP table and BPF compare to each other. All right, so I'm going to skip source IP perception.
And there's an audience question, and I think this could be a good slot for it. We have a question that goes, so this tool will help us prevent against DDoS or scanning cluster in Kubernetes.
So yes, that's why I skipped the first use case, and we're at the second use case. So short answer is yes, you can use eBPF to protect against DDoS. For cluster scanning, you can use it. It's not that it's impossible, but again, cluster scanning would fall into your policies. So it's not mandatory to use eBPF. However, you can use it to get better results. All right. So, as one of the audience member mentioned, DDoS. So denial of service is a type of attack where an attacker overwhelms the resources of a target system by flooding it with an enormous volume of requests. This flood of requests aims to exhaust the victim's capacity to respond, rendering their services inaccessible to legitimate clients. Now that we know how the attack works, let's explore the defense measures that we can employ with both the standard Linux data plane and the eBPF data plane. So in a typical Linux environment, incoming requests are initially received by the network card. Then they proceed to the Linux kernel and the Linux networking stack. At this stage, we can leverage the raw IP tables table to manipulate these packets and modify their behavior or destination. In such a scenario where an attacker is targeting your environment with a DOS attack, the earliest point that you can deny these volume of requests is the IP tables raw. Now, it is important to note that with this approach, depending on the size of the attack, there can be a noticeable impact on your node. This is because these packets must be processed by the Linux networking stack before they can be identified and eventually dropped. Now, to minimize the impact of such an attack, you can leverage eBPF. So, for instance, Calico eBPF and its XDP integration in such a scenario allows you to create policies that can inject XDP programs to intercept these packets at the earliest point of entry. So let's when a legitimate user tries to contact, the eBPF data plane will take the request and send it to the process that is running. So this is something that is ideal. Now, what happens when the DOS attack when a DOS attack starts? Well, XDP integration allows you to interact with these packets at several points in your environment. In some cases, Calico can directly load its eBPF programs into your network card and drop malicious packets before they can even hit the kernel. Keep in mind that this requires a network card that supports XDP integration, and not all network cards are capable of doing this. This method is usually referred to as offloaded XDP. In cases where the offloaded XDP is not supported, the network driver card might provide the capability to load the XDP programs as part of the initial receive path of the traffic. This method is referred to as native XDP. And again, not every network cards are capable of supporting it. If both cases are not available in your environment, Calico will automatically use the kernel to run its XDP programs, which is a great way to run XDP programs on generic hardware that does not provide specific support for XDP. This method is referred to as generic XDP. So, fun fact, Calico XDP integration is available on both data planes, but in the standard Linux data plane, it's a little bit limited. If you like to try this scenario, just scan the QR code and you will be presented with a live environment that allows you to fiddle around with the XDP policies. All right, so now that we talked about these, let's go to the demo part. Any other questions? Well,
Not at
trying
the
this.
moment, but there's a lot of people saying hi, which is always lovely to see. But again, if you have any questions, just send them into the chat. And I think then now that we are at the demo point, we will probably take the questions after the demo at the Q&A moment after.
Thank you, Annie. Now I just need to figure out where's the terminal.
There it is. I see it.
Yes, and hopefully the font is all right.
Oh, the might be a bit small to see.
Is it small? All right?
Yeah, but well, with the colors and everything, but we can try out, how it goes as well.
Oh, I can definitely solve this problem. Let me just change.
It's always nice when there's an easy solution.
Yeah, but it usually doesn't work.
It happens.
Yeah. All right. So, projects, bigger presentation. All right. So now, hopefully, this one is going to be a little bit better.
Yes. Now I think it's looking better. Yes, and with a bit of zooming, I think it's looking good now. And then if the audience, if you're still struggling a bit, let us know. But I think it's getting there quite nicely.
All right. So, thank you for confirming. I'm going to use multipass to run a local environment. At the end of the stream, I'll share all the codes that I'm using. It's going to be in the GitHub page, similar to my other presentations. So let me just and I need to all right. So it's going to be here. Annie would share the link with you guys. Thank you, Annie.
Of course.
it's going to take some time. If you guys got any questions, let me know. This computer is a little bit slow.
It always happens when you need it to be fast. That's for sure.
True, true. That is true.
No questions so far. Let's see if anyone has any right now. I would guess that immediately when we have a question, it's all gonna move forward, and then we don't.
That is
Yeah.
true.
Oh, now we have a question. Can we explain?
Oh, so multipass is an application that allows you to run virtual machines in like seconds. It's something that I usually use to spin up laboratories to run my experiments. It's, as you can see, it allows you to use data. I think it was data user or something, which is Linux startup command for unattended Linux startup script for unattended install. So you can just jerry rig everything into your script and launch a virtual machine, and the result will be something that is working. So multipass list. So that two command gave me two virtual machines that are configured with Kubernetes. It's everything is installed. Nodes are connected. Everything is working, hopefully, and we can do the demo.
Perfect. And after we're done with it, we have a few questions lined up already, but we can finish the demo first, of course.
All right. So, to install Calico, the recommended way is Tiger Operator. Now, if this cluster that you have access to throughout the URL that Annie was kind enough to share is configured without kube proxy. So usually kube proxy is what configures IP table in your Kubernetes environment that allows the resources that you have inside your cluster to be able to talk to API server, other resources outside, inside. So everything happens with kube proxy. Now, if we take a look at the operator here, at some point, it would tell us something is wrong. I think it's going to be like a minute or 30 seconds. So here, as you can see, the operator is trying to communicate with this IP address. We don't know what it is at the moment, and it can't. So if I come to my services, it's like, aha, it's the API server. Now, as I mentioned, in eBPF mode, Calico data plane can fully replace kube proxy. Now, how you can do it is you need to create a config map for the Tiger operator to let it know where the Kubernetes host actually relies. So if you look here, I have a environment variable. This environment variable is giving me back the IP address of my control plane. That's about it. So now my operator knows what's going on. Now, the operator would restart itself and check for the installation. So for troubleshooting, most of the time, if nothing is coming up, just go ahead, figure out what is the log is saying. It could be Tiger operator or any sort of operator. Just skim the logs, describe the pod. It will give you a hint of where to look at. Now, the first problem was easy to debug. So now that we have the Kubernetes API server configured, I can go ahead and check the logs again. Now this time, as you can see, after the after the operator finds the OS, finds the stuff, it goes into communicating with the API server, gets some information that it requires, and immediately stops. It stops for the installation config. So the operator would continuously look for your installation resource. Now, what is an installation resource? It is the instruction that tells the operator in which way you want to install Calico and how you want to configure it. For this demo, these are the configurations. This is the pod CIDR IP. All my pods are going to be in this IP CIDR. For encapsulation, I'm going to use VXLAN. So each time when a pod wants to talk to a pod in another network, by network, I mean, if a pod in node A wants to talk with a pod in node B, and these two nodes are in different subnets, so a broadcast domain doesn't work, it can encapsulate that information with VXLAN and use it instead of the layer 2 ARP discovery. I do have NAT outgoing enabled, so by that means all my pods are right now able to talk to the internet. You can change that. You can make it disabled, or you can create multiple IP pools. You can create multiple IP pools and put your pods into each one, depending on how you want to form your environment. Now, next part, there is another problem. Well, as you can see, everything is running but core DNS. So the default behavior or the default configuration for Calico is standard Linux data plane. Now, there are a couple of ways that you can change the default data plane. So one is you can come here inside your installation resource, around here at Linux data plane, I believe, and say BPF. That's one way. The other way is if you have installed it, you can actually patch it and everything hopefully works. We'll see. You'll never know with a demo. Oh, I forgot to talk about troubleshooting it before solving it. So, in order to troubleshoot this, you can come and check the Calico node logs. Oh, shoot. The pod restarted. All right. And let me just. All right. So, how you can troubleshoot the previous problem. So Calico node is variables to an extent. You can change this configuration, and it tells you a lot of information. You can grep for error and figure out what is not working. There is an explicit thing that says the data plane something is not working. But how you can figure out if BPF is running? Well, you again check the logs for Calico node, and it tells you BPF mode is enabled. You're all set. Oh, one thing to mention here, Calico uses unprivileged BPF. So there was an exploit some moons ago where people could, it's still possible, but it depends on how you configure your BPF environment. For instance, Calico only uses unprivileged BPF programs. So no matter what happens, nobody can use BPF programs in order to exploit your environment. This is some sort of gotcha that I wanted to talk about. Now, next part, I'm going to I'm going to deploy an application and go actually into more BPF troubleshooting. So, as I mentioned, eBPF is BPF programs are binary. So if I go to let's say, one of my nodes, there is almost no way out of the box, similar to, let's say, iptables -l and we not to this. So there is nothing like this sort of command that can give you an insight into what is happening. Now, it's not a fault or it's not a flaw. This is because, as I mentioned, each eBPF data plane or each eBPF program is unique to its community, to its projects. While everybody might use a same hook, they can use it in different ways, or they can utilize it in different ways. So it would be pretty difficult to write a generic tool that can give you unique insights. It is possible to write something that gives you a general performance or general error sort of thing. Like you can use TC, for instance. TC will allow you to run your generic BPF program and get some some outputs about what is happening. TC also gives you a way to like hook into interfaces, but we'll come back to that. So let's say I don't know what BPF is. I have no idea how to program. I enabled the eBPF data plane because of its performance, and I want to troubleshoot it. Now, what is the solution for me? Well, one thing that you can do is ship with your Calico node pod. There is an application called Calico Node, not surprisingly, but it has an option, -BPF. Now, -BPF has pre-prepared BPF programs that you can use to figure out what is going inside your cluster. So, for instance, I can use the contours to figure out what is the ingress, egress, or XDP metrics if I have any XDPs. If you launch the environment that I shared with a QR code, the XDP one, you can actually use these commands to figure out what is going on, how those policies are being used, and you can use this information to your advantage, either performance tuning or troubleshooting. Now, one thing to mention is there are a couple of arguments that you can use with these. iFace, for instance, will give you explicit output about one interface, or you can get all of them. There are a couple of others that you can use. For instance, contract. Now, Linux on its own, in terms of networking, is stateless. There is a component called contract that usually writes where a packet or a flow is originated from, and keeps it in mind for when you want to respond to that flow or traffic. Now, in BPF mode, Calico establishes its own contract table using BPF programs. Now, there are a couple of reasons for this, but the best one is using BPF maps for this sort of things is it's way faster than relying on other sort of hooks. Why? Because with BPF programs, as I said, the programmer can directly tap into the actual place that it needs to read and figure out what's going on and manipulate the traffic or the entries as they want. There are a couple of other things. For instance, there is a NAT dump that you can do. So these will give you what is happening in terms of your pods accessing the internet. By the way, if these outputs are not familiar, don't worry. I'll share a link to the documentation, which these are explained there way better than how I can explain it. It's explained by the clever engineers who build these tools. I'm just trying to talk about it. So there are routes that you can figure out what is going on in the nodes that you have. And one thing that might be very interesting for you guys is policy. Now, if you do a policy dump, you'll get an error. This is because when you want to do a policy dump, you need to tell what interface and what hook Now, the hook is either ingress for the incoming packets or egress for the outgoing packets, or XTP, the one that I mentioned, for DOS attacks. Now, you can use all, but I would say an all is usually used when you want to just get a feeling of what is going on. Anyway, now how this thing works. Let me find an interface name first.
Yeah, no worries. We have about 9 minutes left, and we have about one, two, three audience questions to cover as well. Just keeping in mind here.
Oh, all right. So I'll just do this. All right. So policy dump will tell you what is happening. It will use a TC hook to show you the way ingress or egress. You will figure out how these policies stack up. You can see the actual low-level code for BPF. By the way, if somebody fancies a contribution to an open source, we can really use your help to change this output to whatever you like and add a flag for it. I'll be happy to review it. Not that I would understand what you're doing, but I can get somebody who's really good in this sort of things to actually vet your contribution, and that could be a good thing for a resume too. Again, it tells you what is happening, and with that, I'll just end my explanations and share the link to the mothership.
Perfect.
All right.
So this is the important link now.
Yes.
Perfect. Let's keep it there for a bit while we then get to some of the questions I think that we had. So the first one we have here is Calico eBPF can work with normal Linux system without Kubernetes cluster?
Yes. There's actually a way to install Calico on a standalone host.
Perfect. Easy answer then. Can I use, Reza actually asks, from Reza, can I use eBPF DDoS protection feature for advanced scenarios? Actually, how it understands when it's happening.
So eBPF doesn't understand if an attack is happening. You can use eBPF troubleshooting tools or your monitoring platform to figure out if an attack is happening by monitoring the traffic, monitoring the bandwidth. And if something is happening and it smells, you could write some sort of automation that adds eBPF policies to just get rid of that IP address or that CIDR.
Cool. And then we have a question, which CNI tools prefer to use on premises?
It depends on your scenario. I would say Calico. I can be a bit biased, but there are lots of lots. You can use Flannel, Vive. I don't. There are a lot of CNIs. Just test everything and figure out which one works for you. Hopefully, Calico.
Yeah, that would be a good one. And then we have, can I utilize eBPF for cluster meshing?
Yes, it is possible to use eBPF for cluster meshing. However, I'm not sure. So a cluster mesh is when you connect two clusters together. Now, there are ways to use eBPF for it, but uh, there are other ways too. Yes, you can definitely use eBPF to get those packets, assure them to their destinations. You can also use BERT or BGP or any sort of other protocols too. It depends on like how adventurous you are.
Yeah, sounds good. And then Asif asks, is eBPF open source? Can we use it for testing?
So there's an double entendre here. So eBPF is open source. If you're talking about the programming part of it or the framework that you can use to talk to the Linux kernel, that is open source. If you're talking about Calico eBPF data plane, that is also open source too. You can go change it, run it in your own environment, hopefully submit the changes for us too so we can use your awesome contributions. And can you use it for testing? Yes, you can also use it for production too. It depends on, again, you and your environment.
Great. And then we have the last question so far. And since we have 3 minutes left, so this is also a last call for questions. So if you're typing a question in, send it in now while we answer this so far last question. Do Cisco Juniper also have a CNI solution?
I'm not the best person to answer this because I'm not that familiar with Juniper. I do know Cisco ACS has option to install Calico, and that way you can use CNI in their cloud platform.
Yeah.
But yeah, the best way would be in searching their documentation.
Bit of a deep dive there. Perfect. Um, while we see if we have someone typing a question, I would have a question. If someone's super excited to learn more about the topic, what would be the resource that you would recommend to them to check out next?
So eBPF data plane, the documentation. So docs.tigera.io, as I shared with you. If somebody fancies writing code that directly interact with the kernel, then eBPF.io is a great start. What's it called? The Linux kernel GitHub repository and the Linux kernel mailing list are way way more amazing than you can imagine for this sort of information. But again, it depends on the levels that you want to interact with the technology.
Yeah, sounds good. And now we have 2 minutes left, and we have actually two new questions. So these are the final questions I think that we have time for. So we have, how can we use eBPF for Kubernetes security? I am very new to eBPF.
So, as I mentioned, eBPF programs are directly injected to the kernel. You can use these to manipulate traffic that is facing your Kubernetes cluster, or you can actually peek into what is happening inside the packets. That will be the security view off the top of my mind.
Yeah. Then we have the final question for today, which is, hello, is the eBPF Calico highly available if the eBPF daemon agent crashed, and so forth? So essentially, is eBPF Calico highly available?
So, Calico eBPF data plane relies on Calico node, and Calico node is highly available. So if something happens, it will not drop your connections. Everything goes smoothly, but it what's it called? Try to recuperate on the background and comes back. So again, BPF networking happens with BPF programs that are injected into your kernel. That's about it. If the BPF data plane crashes, the programs are in there and doing their work.
Perfect. And that is all that we have time for today, but so many great questions, which is always lovely to see. So let's wrap it up. So thank you everyone for joining the latest episode of Cloud Native Live. It was great to have a session about troubleshooting eBPF data plane in Kubernetes cluster. And I really love the audience interaction today and the questions. Really great stuff, everyone. Thank you so much. And as always, we bring you the latest cloud native code every week. So tune in the coming weeks as well. And thank you for joining us today, and see you all next